Your homework from the other day. Please say about your homeworks from the other day. Here are the answers to those questions. Can we put everything in? Go like this? Yes. So make sure that it's ready to go through and hand in. The answers themselves are there, as we went over before. Homework should always be on separate paper. We've got to make sure because you're going to be handing it in. If you didn't, you'll have to copy it over and get it in by the end of the day. The one question, and if you have, we'll say this. I get very frustrated a lot of times when you go through and watch some of my colleagues, because they'll literally spend like 2 months going through and doing homework, and you guys are very good at asking so many questions that they don't get through anything. They'll be like, I have a question on 1. I say the answer was, I have a question on 2. I have a question on 3. And the next thing you know, there's no time left for that. So I will say this. There were 2 trends that emerged from the work or the questions that I got this morning. And it's good, and don't misconstrue this. It's very good if you did something and you have a question, because that means you were put in a situation, you correctly analyzed the situation, and you said, I'm not able to do it, but I do want to do it. That's everything that we hope that you do. The first one up was how to answer 10A. And if I remember right, 10A asks you to go through and graph it. Now, you need 2 points in order to graph a line. That's it. You just need 2. So, if I went through and did this, the easiest 2 to find are the x-intercept and the y-intercept. Now, this to me was a little bit frustrating. I'm not frustrated with you. I'm frustrated that there's so many of you that come in. I guess maybe it's the first section that didn't know this. Because do any of you know how you can go through and find the x-intercept? You're given an equation like you were in number 10. Literally. Yeah, you make the y value equal 0. That's going to give you a point. So if I make the y value 0, the x comes out to be 360. And how would you find out what the x-intercept is? Well, you would go through and set the y equal to 0 and solve that out. And if you do, you get 1,000. The next question for B was, what do they mean? That's one I'm hoping that we could have got, but they don't spend a ton of time with you all saying, well, this is what this means in context. Well, put yourself in the situation. What does the x mean? Or sorry, did it ask what the x or the x-intercept meant? Oh, what do the intercepts mean? Excuse me. So the y-intercept means that if I sold 0 of the x's, I would have to sell that many y's in order for it to happen. Now, in this case, the y-intercept means if they sell 0 hats, they need 360 sweatshirts. And the other way is if they sell 0 sweatshirts, they need to sell that many hats in order to get the money that they need. That's the only thing that it's asking you. Now comes the bigger question, and putting it in a real-world context. Some of you may have graphed this out in quadrants 2 and 4. Why does this graph not exist in quadrants 2 and 4? Hands up, please, if you can tell me why, if you were asked to graph this with all that you know, why you would not sketch it out in quadrant 2 or quadrant 4. You got one person? Yeah, you can't. The X in this case was the cap. The Y was the sweatshirt. You can't sell negative of something. That's not possible. You only need the 2 points there to graph it out. The other one that came up was the calendar questions. There were about 5 or 6 that came in with it, which means there definitely were more that just didn't come in. But in any case, you now try to go through and do it out on the computer and turn it into a picture and text it out to you through Remind later today. But when you have something like that, the very first thing that I ask you to show is give me a sketch of what it is, and a legitimate sketch of it. So I'm not asking it to be on Cartesian or on the Cartesian plane, but give me an exact one. Give me just a rough sketch. I know what the points were. So I'd sketch out point A, which is the point 2, -5. That's in quadrant 4. B is 0, 4. That's going to be a quadrantal between two quadrants. And -3, -1. That's going to happen in quadrant 3. And I had some kids that came in, and again, you've got to show me that you're giving me something. And they said, you know, I don't get how to answer with what this is, but I know how to find the altitude. So they're showing me, I know how to do this. Well, I just need to sketch what that slope is. So piggyback off of what you did, find out what the slope of the altitude is, and use that to go through and figure out what the line is through C. And the other one was the median. And we said, well, wait a minute. What's the median? Now, the district gave you, I think that they're about $300, so $270 worth of technology, or you have it on your phone where you type into Google, what is a median? Now, then somebody came back and go, I looked it up. Why are we talking about something in the road? Look for maybe the math definition of median, because the question isn't referencing the part of the road that's dividing oncoming traffic from hitting you. So make sure that you go through and look it up. You would be shocked at how much you'd have to, what is it called? I think it's called Spark Notes. That was one. Is there one called like Schmoopel or something for books? What's the one for books that you don't have to read the book, you can look it up? Cliff Notes, right? You use it for that. Mr. Paul and I go out to dinner probably once a month, and I hear all of the stories about how the plagiarism that goes on. People literally cutting and pasting paragraphs from. I thought it was, maybe it's Schmoopy or something like that, but Schmoop, that's it? Okay. What a great name for the website. In any case, they go through and copy the exact paragraph and then submit that as their own. You're using it for English all the time. Try using it for math. Like if you get stuck, if you don't know what a word is, type in what is a median, and then if you're frustrated, you say this, what is a median in math, and then hit enter, okay? And you should be able to go through and get it. Now, make sure your name is at the top, please. If you need a stapler, there's one on my desk. It's an electric one. You actually make sure that your paper goes in like this, not at an angle, and you actually have to push it in a little bit. I will caution you, it's incredibly high powered. And I think it's so strong that it's illegal to have in America. So make sure you cover your eyes when you use. I don't want anybody going blind because of a stapler in this side. But in any case, if you need to staple it, go over on the side and staple it. Let your nose hand it up and over, please, and have out your notepad. Get something to where we left off last time. And by the way, I get it. The packet is in small print. If you want a nice big copy, where can you go? It's posted through Google Classroom. So if you got 2 pages that need to be stapled, put them over on the side. Just put the corner in. It's on my desk. If you face from the other end, it's easier to see where it is. It's right next to the phone. Okay? Yes? Yeah, do this here. Ready? Come on. Save one for another time. Yep. Yep, hand them up here.
So I have the graphs on a separate sheet.
All right, do this, because you're going to need that packet going forward. Here, I'll give you some loose leaf. Make sure, guys, when you do your homework, it's on loose leaf paper, because you're going to be handing the homework in, and you're still going to need the packet itself. So if you didn't do that, that's fine. Just make sure it gets done by the end of the day today. So just copy over your work that you did on there, because you need that packet for your homework for tomorrow. Where were did we go over that last time or no?
Same mistake, though.
See? And there's always someone, listen, I get it. I'm very particular in the beginning, but I don't want you to hand me your packet if you guys aren't going to have anything to go off of in the future. Thank you. All right. So if you didn't get it done, that's fine. Get it in by the end of the day. No rush. The stuff that we're doing today hopefully is more review than what we had before. So we left off, we should be on topic 1.2 or 1-2, whatever it ends up being. I think it's on page 7, is that right? All right, so go into your note package, please. Open them up to page 7. It should look like this. What we're going to talk about in the beginning is this. We're going to talk about relations, functions, what is a function, what isn't a function, the whole deal. Is to determine something critical, because a lot of things in algebra have to be functions in order for our rules to apply. So if they abide by these set of laws, we're able to go through, or if they meet this set of properties, we can know a bunch of traits that they're going to exhibit. The first thing up that you need to make sure you know, a relation is a set of ordered pairs. It's a bunch of mappings of inputs and outputs. It does not mean that it's a function. The definition for a function is different. A relation is just a mapping of inputs and outputs. Now, each of these is going to be a relation. We're going to talk about something else that may be new. Well, hopefully it isn't new for you. I know you did it back in Algebra 1. We're going to talk about something called domain and range. We're also going to work with a little bit of interval notation. The first thing we need to know is what domain is. Does anyone recall what the domain of a relation or a function is going to be, or anything to remember about domain or range? You did? Yeah? Which one is the y? The domain or the range? Okay? If it's not the domain, what would it be? Yeah. So the range is the y values that you use. The domain is the input values that you use that give an output. So looking at what we've got, and this is a pet peeve of mine, when we list out our domain, we're going to list it out from least to greatest. Here are my 3 inputs here. So it's 1, 2, 3. I'm going to list them out from least to greatest. So I'm going to go through, and since it's individual numbers, I'm going to use the fancy brackets. It's going to be -9, comma 1, comma 3. We ask that you list them out from least to greatest. Now, the range is the y values. So looking at what's there, Christina W., what would your y values be?
0, 3, 5.
Perfect. Now, let's think about what the graph is going to look like in 2. Hands up, please, if you can tell me what shape that's going to be if you go through and graph it. This is the part in the other class where hopefully the question's supposed to be kind of easy. It's not supposed to be tough. What we graph that, we say it's the graph of a, what do you want to say? Linear? Yeah, it's a linear, it's a graph of a line. So, and you should be able to give a good idea of what this graph looks like. Without it, I go over to the mark and say, all right, the graph, we know the y-intercept is -5, so that's down here. The slope is +7, so it looks something like that-ish. Now, the domain on this is going to be the inputs that give you an output. So, that means we're moving left to right. This graph extends forever to the left without interruption. And it goes forever to the right without interruption, which means the domain is everything. Everything is in the domain of that line. Now, when we say out what that's going to be, there's 2 ways you can give it out. Sometimes the state exam will use this to mean all real numbers. However, to get yourself ready beyond this year, we don't use that notation, nor do we use really any quality notation that much anymore. We give things out in interval notation, which means it's a lower bound, comma, upper bound for each set that we would use, so we'll say or. Now, the other end would be interval notation. This graph, we just said, it goes forever to the left and forever to the right. And it goes, and in terms of an interval, it would be lower bound, comma, upper bound. If we extend way out forever to the left, that means I'm going to -infinity. And if I extend way out to the right, it's going to +infinity. Now, for the work that you do in here that's in pen, meaning the stuff you're writing, you're always going to be asked to put a sign on your infinity. So if it's positive, tell me positive infinity. If it's negative, tell me negative infinity. On the Math Excel homework, you won't have to do that. If you check, sometimes it'll be people come in and go, well, it says it's wrong because I put the positive, and it is wrong because their program doesn't format it that way. Looking at the range, that's how high and low the graph goes. This graph falls forever and rises forever. So your range would be all real numbers, or negative infinity to positive infinity. Now this one, because of the graphing program that we use, something's a little bit off. Maybe we should put arrows on the ends of our axes. If they're not there, get used to putting them in, because you will lose points if they're not there on yours. Looking at what's here, let's first identify what your domain is. So, where's Jessica? What's your domain going to be for this? Domain is the input that give you an output. So what would that be as an interval? Yep. Our domain is going to be negative infinity to positive infinity. You could use the all real numbers for this. We ask that you use interval notation most times. Now the next one's going to be a little bit more awkward. We've got to figure out what our range is going to be. So, John Paul, what is the lower bound on this? Or how low does it go?
0.
And what's the upper bound on it? Yep, so what would you give out your range as in interval notation? That's the upper bound. What's the lower bound?
0.
And am I putting a bracket or a parenthesis there? Do you remember? No? That's going to be a bracket. Does anybody know why this is a bracket here?
Does it include 0?
Yeah, if it includes the value, you put the bracket. Now, just so you're aware, the reason that it doesn't ever include an infinity sign is infinity isn't a number, it's an idea. Now, when we're looking at this next one, my domain would be January, February, and March. My range would be Sue, Joe, Amy, and Ed. Josh not being there, not being included, doesn't mean he's in the range. Just the fact that it's written doesn't mean that it's in the range. Now we're going to talk about something now and look at some characteristics of these last three that we did. Looking at what's here, you should be able to know, well, let's say, does anybody remember what a function is? We'll talk about it in a minute if you don't. Does anyone remember the definition of what a function is? I think we did. What I understand, there was a 3-week unit on it back in Algebra. Okay. So a function is a relation where every input only has one output. Looking at what's there for 4, 4 is not a function. Can anybody tell me why 4 would not be a function? We got 2 people, 3. What do you say? Yeah, February has 2 outputs. Now, if something is a function, there's other subsets of functions. A function is onto if every available output value is used. Take a look at example 2. Is this a function? Yes. Every input has at most one output. Is this an onto function, meaning is every y value that's listed used? Well, it drops down forever, so all of those negative ones are used. It rises forever. All of the positive ones are used. That line is going to be an onto function, or a function that's onto. 3 is not an onto function. Hands up, please, if you can tell me why 3 would not be an onto function. What's there? Why would 3 not be an onto function? One person? Really? 2 of us? What does 2 do that 3 doesn't? Sorry, what does 2 do that 3 doesn't? They exist. The negative y values exist. Is our graph ever going to hit a negative y value? No. So is the function onto? No. Some people then started arguing that example 4 wouldn't be an onto function. And I said that they're wrong. They go, this is not an onto function. I go, well, you're wrong. Why would they be wrong? There's part of that I guess they weren't paying attention the first time.
Non-function.
It's not a function. If it's not a function, how can it not be an onto function? Now, if we go over to the next page, your domain, we talked about before, is the set of all usable inputs. In our case, for the reads, they're x values exclusively. The range is all of the outputs used in that relation. Go back and state the domain and range where we did that the first time. The domain is the inputs, the range is the outputs. If something is a function, if every input has only one output, questions on this one? All right. Looking at the next group, when we need to state the domain and range of each of these. So let's go through and fill those in with what they are. 1A should be easy. Let's hope. What would our domain be? Catherine, what would you say your domain is in 1A? Why is it brackets and not parentheses? Close. What do you want to say? Yeah, because it includes the 4. If it only went up to but didn't include it, we'd use parentheses then. And Jared, what would you go through and have for your range? Questions on that? Now, let's look at what's happening in B. And B is a little bit awkward, so sometimes it's easier to get the domain by looking at where there's a problem area. Who can tell me a value that's not in the domain of B? Look at there. What's not in the domain of B? We can see easy kind of what is in the domain. What would not be in the domain of B? Give me a second.
0.
0 is not in the domain. Is there anything else that's not in the domain? No? Look at left and right. As I go to the left, it continues forever. As I go to the right, it continues forever, except for this problem that we're going to have here. So I would say that my domain is, now, it goes lower bound, comma, upper bound. When we see this, you have to recognize there's sort of two pieces of this graph. So to represent that orange line, I would go to the bottom one here. I'd say it's negative infinity, goes way out. It goes way out to negative infinity. And it keeps going till I get to 0. And then it starts at 0 again and keeps going to positive infinity. You don't put a bracket there because it goes up to the 0, but doesn't include it. And it's the part that always gets me is when I put this here, you think that that's the x value. The x value is the one going side to side. The y value is the one going up and down. Now the range is different. The range is the outputs or y values. So look at that graph. What's a value that's in the range? That's you. That's terrible picking. All right. Now, this isn't the right answer, but this shows me you're on the right track. Because this is really awkward to get in the beginning. And I'm going to say it this way. Based on what you said, you gave me too much. Does anybody know why this answer is too much? 1, 2, we always get this. What do you want to say? It does. Because like right here, the y value is -1. And up top it would be +1. It doesn't include 0. to see how the graph, like right now, you're saying that it includes 0. Does the graph, as we go up and down, go through that point? Mm-mm. Does anybody know how, I guess, we could modify it or at least see the problem in this? Because what values are in the range? Only -1 and 1. So, and we haven't shown you this yet, at least in this context. You see the right values, the formatting of them is just a little bit off because you're including too much. So, we could state it this way, as though -1 and then +1. Or, you could go through and state it this way as a -1, comma 1. Either of those works. As a set, you're saying it's -1, union 1, or -1 and 1. But we can't include this middle area because nothing in the graph doesn't go through anything in the middle there. But seeing those values themselves and the structure of it is good. We were very close. Looking at this, a function is a relation in which every element of the domain corresponds to, it really should say at most one element of the range. Looking at what's there for 2a. Cassie, what do you go through and say for 2a? Is that a function? What's the problem area? Why is 2a not a function? For which input? February is the problem area. February gets mapped onto 2 outputs. Alexa A, what would you go through and say for 2b? Is that going to be a function? Is it an onto function? Why? No, that can happen. That, by the way, means, notice how you said something else. And we'll talk about this later. Did you guys talk about what a one-to-one function is, or no? Okay, that's a big concept in Algebra 2 as well. You brought something up that we didn't talk about yet. When you do this, notice how this is a function. Every input has at most one output. Notice how January and February both get mapped to Joe. If the outputs aren't unique, it's not a one-to-one function. Is this going to be an onto? You said no. Can anybody tell me why? 3 people, 4? No. That makes it not one-to-one. Not all of the available outputs are used. It's not onto because Sue and Amy aren't used. Now, just so you know, when we do our stuff this year, you're doing the same. We're doing the same courses they're teaching. Me and a friend, 2 friends got together to design everything. And it's the stuff that we're doing now is the same as stuff in Pittsburgh and at Fayetteville Manlius, which is in Syracuse. So sometimes I forget to go through and change the name of their high school. That's what FM stands for. But let's say it this way. What about if we did Schrader students mapped onto their guidance counselors? So think about that. The input is the Schrader students. The output is their guidance counselor. Is that going to be a function? What would we say for that one? What's Hannah do? Hannah, would that be a function? Why not? No? Be careful. How many guidance counselors does every student have? You're viewing it the other way. The input is you. How many guidance counselors do you have? 1. Raise your hand if in here you have 1 guidance counselor. Does everybody have 2? All right. So this would be a function. Going the other way. Do you know who the guidance counselor is? Who is it? Who has Mrs. Lindsay as a guidance counselor? All right. Going in that direction from guidance counselors to Schrader students, is that going to be a function? Why not? There's 1 of her, and how many students does she have? A lot of them. So the relationship from you to your counselor is unique. Your counselor's relationship to you is not. How about for E? Is that going to be a function? Alex, what do you say?
Um,
Take a look at your inputs and then your outputs, or your X's and your Y's.
yes.
That every input has only one output. Questions on that one? Now, how about, I don't know if you talked about this. Did you remember hearing the words vertical line test before? It's a very, very lazy definition of how functions, what is a function and what isn't. But they let it slide, and the 8th grade teachers, when they teach you algebra, they don't come from the strongest foundation, so they try a lot of shortcuts. Looking at what's there, A is going to be a function because it passes the vertical line test. Now, what the vertical line test means is, for every x value, which is this number, this x, is there only one output value? And in this case, there is. Now, that means, by the way, that this would be a function. That's what the definition of the vertical line test does. Why is it B going to be a function? Well, all of you would go through and say, it fails the vertical line test. That's not good enough. I mean, it's good enough for the regions. Can everyone tell me why this would not be a function? Yeah, we can do better than that. That's a good start. We can find an x value that has two y values. What do you think that, if you were to guess, are we okay with saying this is x is -1? See how the graph has two y values? That's why it's not a function. Saying the vertical line test doesn't mean that it's not a function. I mean, we'll accept it on tests in physics, but we're getting you ready to take calculus. Now, the next thing that we need to know is what functions are and what function notation is. Functions are sort of like a machine where you go through, it can be stated as a rule or as an equation. I'm going to tell you this right now. You all should be profoundly familiar with both of these notations. And when we talk about function notation, it doesn't mean y equals. Function notation is a really complicated way that you kind of probably haven't been explained before. This f right here is the name of the function. The reason being, when mathematicians would write to each other, they'd be talking about 40 different functions. They don't want to keep writing the full thing out every time. So they'd name them f of x, g of x, h of x, and so on. But you could name it a of x, b of x, c of x, d of x, h of x. The only thing you probably want to stay away from is x of x. This is naming the function. So this is a function name. This is prepping you for what the input is. So this is telling you, take the input, cube it, and add 3. You could go through, so f of a star, right, would be equal to some star to the third plus 3. That's what it's telling you to do. It doesn't have to be an x there. Now, the other end of it, and the bottom one is the one you're most used to seeing, gives you the output is equal to the input cubed plus 3. This is saying for function f, we're going to define it as the input plugged into this function. And this one is saying x as a function, or sorry, x inserted into function f would be that. These two in yellow are going to be the ones you see on the exam. In terms of thinking of what the relationship is that you're explaining, this right here is your input. So I'm going to take my input, I'm going to plug it into the function here. And then I'm going to get an output value. This would be your domain, this would be your range, and this would be the f of x, or the function itself. That's what function notation means. Questions on there? Now we're going to look at, and this is one, I think we went over it the other day. You didn't hear Cartesian plane before this year, is that right? That's right. Raise your hand if you heard of Cartesian plane before this year. Raise your hand if you hadn't heard of Cartesian plane before this year. Raise your hand if you know what a Cartesian plane is. The XY plane that you've been graphing on the whole time. Except there was a guy, I don't think his name was Cartesian, but maybe we'll name him like Cartont or something like that. he came up with it and standardized it. So when we talk about a Cartesian plane, that's a standard graphing window that you're working with. So when I say Cartesian plane, please know that that's what we're talking about. The other things that get a little frustrating that your algebra teachers didn't do before. So let's say I have this, we'll make this the quantity x minus 3. This is a radical. And did we tell you what goes under a radical? What the name of this expression here is? That is called, the outside symbol is called a radical or a square root. The value underneath it is called the radicand. And when we're talking about the input of a function, another way to say the input of a function is the argument of a function. After you get out of high school, you don't say the, input anymore. You say the argument of the function is this or something like that. Now, to start off with, it defines g of x, or g of my input, is equal to the input, square root of the quantity of the input minus 3. So to evaluate out g of 3, the first thing I do is I'm going to list this out. And instead of having it be x minus 3, I'm replacing the x, or the input, with the 3. Now you all should be good at this. It was in the first section earlier today. When we did this, they go, all right, so what's the radicand value going to be? And understand that there's maybe times during the year where I have a heart attack or a stroke based on the answers that you give. But all of a sudden I heard somebody, now keep in mind, I said, what's the radicand simplified to? And I saw this. Why would it be disheartening if you're holding your calculator right now to get this done? What are you computing again? So, what is the radicand going to simplify down to? Okay. See? You're good. You guys are enriched. Now, this is where there's a big debate. It's probably close to a 50-50 divide. At least in the first class of class. Can we take the square root of 0? Now, if you don't answer, we're going to do a quick poll. Raise your hand if you say yes. Raise your hand if you say no. If you don't vote, we will watch. Now, the problem is, I'm a little disheartened by the results of our election. The square root is asking you, what times itself gives me this value? I know that this is tough. What times itself gives me my radicand, or 0? Anybody tell me a value that times itself would give me 0? 4 people? So what's the square root of 0 going to be? 0. Again, if I see, maybe I'll even let, you can use it to check your book. I won't judge if you go in and type in square root of 0. I'll let that slide. Take a look at B. It's telling you in the input position of g, I'm going to take m cubed plus, or squared, excuse me. So I say, all right, this is equal to something plus 3, and in that something spot, my input, which is here, I'm going to plug in, so it's m squared. Oh, what did I screw up like a dog? Now, who can tell me what my radicand will sit? Just the radicand. Look at what's there. What is the radicand going to simplify down to? M squared. This is another one where your algebra teachers probably taught you the wrong stuff. So we're left with m squared. What's the square root of m squared? You're going to say it and it's not right. I'm not judging. Go ahead. What do you want to say? Close. It's the absolute value of m. Because let's say I plug in a negative number. If I plug in a negative number, square it, what did I just lose? What did I just lose if I take a negative 7 and square it? You lost the negative. Because what's the square root of 49? But wait, what was my input? Negative 7. So that's why you need those absolute value bars there. I've tried to explain this to the people over at Spry 100 times. Apparently they still haven't picked up. But, are you smarter than them? By a lot. Why? Because you know what the radicand is. And, what is that thing called that we graph on? See, now you sound like college students. The value under the radical, what's that called again? What's the top of a fraction called? Numerator. And the denominator?
The bottom.
Oh, let's ask this. What's the line between the numerator and denominator called? Raise your hand if you remember. I thought we went over it in class. Didn't we do that in class at the first day? Oh, even this. Now, and I know this because, and I saved it when I got it. It was a Snapple fact of the day. I polled the entire department, and only 2 people knew it. So, if any of you had Miss Miller before, what'd you for computers? She's the smartest person to go. I mean, she's good. She's good. If you go through and you have a numerator over a denominator, this line here, and we ask them where they go. That means division. I didn't ask what it means. I want the name of it. Called a vinculum. How amazing is it? Now, you want to talk about making you intelligent and sound like a college student? You could say, imagine how smart you're going to be when you walk in with Miss Weiss next year. And you go, oh, Miss Weiss, I noticed I had a 7 above the vinculum, but a 4 underneath it. She's going to look at you like you have 2 heads. No clue. No clue. You're going to sound so smart. And then she'll go, what is the vinculum? What is that, a disease? You go, no. It's the line between the numerator and the denominator. She means you mean the top and the bottom? No, because fractions don't have tops and bottoms. Now, the last one we're going to try out of this grouping is this, and we're going to bounce around a little bit today. We're going to take and evaluate out g of 0. Now, this gets us into a fabulous discussion. You're going to have the square root of your input minus 3. So in this case, our input is 0, right? So we're to this point. Now, I'm going to go forward, hopefully, again, hopefully I'm not hearing any calculator buttons. We've got the square root of negative 3. We get to this point. Now, can you take the square root of negative 3? Well, if you get stuck, just remember you're asking yourself, what times itself gives you negative 3? It doesn't matter what number's under there if there's a negative sign in front. As of right now, you can't take the square root of a negative number. Now, I wrote this down, and please don't miss. There was a couple in the first class who started raising their hand and go, I don't know what that means. Now think about, just let's process for a minute. We just said, does that simplify down? No. So, what do you think if we give DNE as a final answer that means? Does not exist. There you go. Now, so if you see that sometimes that's what comes up, understand that why we can't have that. Now, later on in the year, we're gonna change our tune because you can take the square root of negative numbers. We just haven't opened that door yet. So we're going to go through and say, obviously, 0 isn't in the domain of x. Why? Because you can't go through and get an output from it. Don't get it confused. The 0, some people go, well, I can plug it in. It's in the domain only if you can get it as an output. Who can tell me another value that's not in the domain of this function? What's an input that won't yield an output? Look at the g of x. What is an input that won't yield an output? Just tell me one. Negative 2. That 2 won't work. What else? Is it just those numbers that aren't in there? What do you want to say? 1 doesn't work. Who's got another one? There you go. You could go negative 50 if you wanted to. Now, we're going to talk about some other things that we're going to get quickly, so we're going to bounce ahead. A function, we're going to have 2 things we're talking about domain that you really need to be on the lookout for. You can't take the square root of a negative number, and we're going to put a big old yet. And if an expression is undefined if you divide by 0. Did I show you this yesterday, the way to check whether you can do it or not? The 0's in the numerator, it's okay. The 0's in the denominator, you can't get an output. What's 0 over anything going to be? 0. The only way you can get, and notice, put a mental star next to this next sentence because you're going to come up for a second. The only way you can get a 0 value from a fraction is when the numerator is 0. Because 0 divided by 5, 0 divided by 1,000,005,000 is still going to be 0. You don't get an output from with a 0 in the denominator. They're just saying how many times does the denominator go into the numerator. Now, we're going to do two, and I hate to say this. We're going to state the domain and range of each of these. Now, I'll say this. Some of you will get it. Think about the x's that I can plug in and get an output for. What's an input that I can plug in to this equation and get an output? You tell me. What's an input? I can say this number, all right, I'm going to take the square root, add 2. I don't need a calculator, I can bang that out. What do you want to say? 2? Can't do that in my head. Square root of 2 is what? Yeah. Give me one. What do you say? 4? All right, plug that in. What do you get as an output when you do 4? So I go 1, 2, 3, 4, and my y value would be 1, 2, 3, 4, because the square root of 4 is 2 plus 2 gives you 4 is the output. Who can tell me another input I could take? 9. All right, if I did 9, I get out what is an answer? 5. 0.95, 1, 2, 3, 4, 5, 6, 7, 8, 9. 5 would be right about there. I got 2 more I should be able to give. Can you tell me one of the 2 more I could give? That's going too far. You're right, you could do 16. 1's going to give you an output of 3, and I can plug in a 0 like we talked about before. So the graph, if you had done it in your calculator, wouldn't look like you did it on a plane while it was landing. Your domain is going to be everything from 0 going over. Your range, now the range is interesting. What's the range on that going to be? Take a look at what's there. And part of that's wrong right now, too. None of you catch it. Who can tell me what's wrong about what's up there? No takers?
It includes 0.
It includes 0. Who can tell me what our range on this would be? Hands up, please. Lower bound, comma, upper bound. How low does the y value go? This is a line. Y-intercept at 4, slope at 3. What's your domain on that going to be? Negative infinity to positive infinity range. We're making these suppositions that you can do those. Coming from Geo, we're hoping that you have a geometry foundation to build off of. We know that that's going to be a line. If y equals 3x minus 4, you know the y-intercept's negative 4, slope of 3, so on. Questions on that one? Now, I'm going to tell you this. I may have to have you, who got the message the other day to go through and watch the video? 2 people, seriously, 3 of you got the message? Who did it? Okay. When I send it out to you, it's kind of, you're going to be falling behind because we go through a lot, and there may be 1 or 2 examples that we don't get to. It's the expectation if I send it out, we'll need to finish 2 questions. So, the other class did get A done, so I'll try to send it out again to you all to make sure that you get that last example. What value, let's ask this before you go, there's 2 things. What value is not in the domain of A? Who can tell me what value we cannot have in the domain of A? Everything works except this one number that causes everything to fall apart. No, not 0. Negative 2. Why negative 2? It adds up to 0 in the denominator. Now, before you go, your homework is in the packet that you had. It's the next set of questions. They go in order. The worksheet references the questions at the front. Look at the chart that's there. But it tells you to do worksheet, was it 1.2 or 2.1 or something like that? Yeah, you don't have that worksheet. So can you do that worksheet? No. Make sure that it's done on separate paper, please, for the next time we meet. All right? Thank you. Have a good day. Food.